who's also on the line. Steve will be addressing regulatory policy and legislative matters, and then myself. My name is Neil Jones. My group covers real estate matters, including utility crossings and non-environmental permitting. Now, we both work for a company called Direct Connect Development Company, and our firm originated the SOO Green project and was originally charged by our investors to develop the project. So one thing I wanted to say was, regretfully, our colleague Raj Rajan, who was scheduled to join us to discuss environmental and permitting items, he is unable to join us today. He's traveling due to an unforeseen family emergency. So I ask that you bear with me as we get to and through his information. You're stuck with me for his portion of it. So today we're going to start with a 4.5-minute video. That video can also be found on our project website, which is soogreenrr.com. I've got a link to that in the presentation. And this video is, I like to start most of our presentations with it because it provides a solid overview of the project, and then it provides some helpful illustrations to better understand the various concepts that we're going to cover. Then after we look at the video, we'll go over approximately 10 slides, which will address some of the same items, but with more context and a little bit more detailed manner. So in all, the formal presentation portion should cover around 25 minutes, give or take, depending on how fast I speak. And then Steve and I will be able to answer questions from the group. And having looked at a couple of the previous videos and the questions that the groups posed previously, I'm looking forward to what you guys have for us. So like I said, Heidi, since I am connecting via my audio over the phone, I ask that you just text me, or not text me, but send me a note if I need to bump up the volume with that. So having you give me the thumbs up, let's try the video.
SOO Green HVDC Link is an innovative new model for electric power transmission development and construction. The proposed project will change the way transmission is built in the U.S. while connecting abundant renewable energy resources in the Midwest to new markets. SOO Green will be the first transmission project in North America to be installed underground along existing transportation corridors. This will minimize environmental and physical impacts and eliminate visual impacts. The same model is successfully used to build America's fiber optic networks. SOO Green will follow existing railroad and Department of Transportation rights-of-way, stretching from the Midwestern U.S. grid in north-central Iowa, running along the Mississippi River, and ending in the eastern U.S. grid in northern Illinois. This project will employ 3 distinct methods to build the underground transmission line: open trench, jack and bore, and horizontal directional drilling, HDD. During open trenching, SOO Green will dig an approximately 3-foot wide, 5-foot deep trench and will bury 2 8-inch diameter conduits. The trench will be backfilled, creating a duct bank with a minimum 3-foot ground-level clearance. Once the duct banks are in place, native soil will be replaced and restored. At this point, cross-linked polyethylene insulated cables, each about 5 inches in diameter, will be pulled through the conduits. These installations require no coolant fluid. Once in place, the trench will remain closed for the life of the project. When a sensitive habitat, existing road, or existing utility needs to be crossed, SOO Green will utilize the second construction method, the jack and bore method. In this method, crews bore under the area, placing both conduits within a single bore. The final method, horizontal directional drilling, is used when crossings are required to be wider or deeper. This includes areas such as wetlands or rivers. After drilling and widening the hole, the conduits and casing will be pulled from one side of the river to the other. Both jack and bore and horizontal directional drilling can with no environmental interruption or surface impact. Following construction, The land along the project border is returned close to its original state, and the line is put into service. The SOO Green team understands the importance of existing infrastructure along the proposed route, including drain tile, which is an integral part of Midwestern farming activities. When intersecting existing drain tile, smaller tiles will be cut and capped to allow the trench to be dug and the conduits to be installed. Once conduits are in place, the tiles will be repaired and the trench will be filled with existing native soil. Depending on current use and flow rate of drain tile, conduits may be placed under larger tiles without cutting. SOO Green's partnership with the railroad will limit impacts to the environment and neighboring communities by reducing the need to remove trees, minimizing sensitive habitat disturbance, and eliminating visual impacts of overhead towers and cables. The SOO Green HVDC link will create thousands of jobs during construction and dozens of permanent jobs to maintain the transmission system. Additionally, SOO Green will reduce existing transmission constraints, enhance grid reliability and resiliency, and enable the development of additional renewable energy projects in the Midwest. The SOO Green team looks forward to working with landowners, policymakers, and local communities to rethink how we build the transmission grid of the future.
So Heidi, I was trying to respond and I did not realize that when you tried to respond on chat, that would pause the video. So yes, you can. I apologize. Those are the glitches. But yes, if you wanted to talk about, given the size of our group, how we want to do the Q&A.
Yes, thank you. So everyone feel free to type questions as you think of them into the chat. We're going to do all of our questions in chat and keep all of the audience on mute. And then when Neil and Steve are through their presentation, Joel will read those off and we'll get as many of them answered as we can. Thank you.
Good deal. Okay, so now that you've got a foundation of the video, once again, that's on our project website. Thank you, Heidi, for providing a link on that. And if you want to view that again via our website, or obviously you can watch this video again, you can. So I don't normally add this portion, but given the audience, I thought it might be good for you to appreciate all the different subject matter experts that are a part of the diverse group that's a part of making a project like this happen. So I wanted to bring out highlight some of the key players with our development. At the top center, you'll see Direct Connect Development Company. This is the company for whom Steve and I work, and we are the project developer, like I said before. And then at the top left is CIP, which is short for Copenhagen Infrastructure Partners. Now, CIP is the project's main investor, and they're based out of Denmark. And one of the reasons they were selected is because they have significant experience with similar underground HVDC projects like this in Europe. At the top right, you'll see the Canadian Pacific logo, who owns the railroad right-of-way. And although they're not an investor, they are a strategic partner in the SOO Green project, and they're the ones that are allowing us to use their corridor. Siemens is also an investor in the project. They are, and they will be also helping us design the converter stations and then providing the AC to DC conversion technology. Jingoli Power is the project engineer, and they round out our investor group and will be providing design and construction expertise for the project. At the bottom center is CLS, which stands for Contract Land Staff, and CLS is the group they're a key part of my real estate group, and they're the folks that are primarily interacting with landowners during these agreement discussions. And the rest of the group represents others on our development team that have and continue to assist us with environmental survey, public affairs and media, transmission design, transmission market analysis, and other matters related to legal, whether it be real estate, regulatory, or otherwise. So once again, we've got a broad range of experts in a lot of different focus areas that are from a lot of different companies, but we're all waving the SOO Green flag and essentially making a project like this a success. So stated briefly, SOO Green is a proposed 350-mile underground high voltage direct current transmission line. That's where the HVDC stands for. And that project, the project will extend from Mason City, Iowa to the Plano-Yorkville area in Illinois. Now, SOO Green is the first major transmission project that will cross the seam between two of the largest regional electric markets in the United States. So to the west, you've got MISO, which stands for Mid-Continent Independent System Operator. And then to the east, you've got PJM, which is Pennsylvania, Jersey, Maryland Independent System Operator. So these regional markets are, it's good to think of them kind of like air traffic controllers for their portion of the grid, and they monitor and coordinate generators and transmission to ensure there's enough electricity for their users. To give you a little bit of idea of scale, MISO serves approximately 42 million customers across 15 U.S. states, as well as the Canadian province of Manitoba, whereas PJM serves over 65 million customers across 13 states and the District of Columbia. So once again, SOO Green is going to cross the seam between these two large markets to bring abundant Midwest renewables to new markets and help provide increased grid stability. So slide 5 shows a wind speed overlay across the Midwest and Eastern United States from the Dakotas all the way down to Texas, and it helps explain the need for a project like SOO Green. So as you can see, the central part of the U.S., like I said, from the Dakotas down to Texas, enjoys some of the best wind resources on the planet. So along with these abundant wind resources, wind generation technology advancements have driven the increased development of wind power in the region over the last couple decades. So you already know this if you've driven west through Iowa. You can see the expansion of wind development. Although the amount of generation has significantly increased, though, the transmission system supporting it has not increased to the same degree. And so this disparity has created transmission constraints within MISO. So even though there are vast amounts of renewable energy being generated, and there's a lot more in the queue that can be built, the ability to transmit that generation to areas of demand are currently limited. And additionally, the PJM market, as you go east, does not enjoy the same abundant wind resource as does the MISO market. So that, along with greater population density and more complex terrain within PJM, makes siting a wind project within that region much more difficult. So, if you want to think of it, the average wind farm in PJM is just not as efficient or cost effective as the average wind farm in MISO. Okay. I just wanted to check the questions real quick. We'll address those later. So these two factors are going to work together to create the need for a project like SOO Green. This project will not only help alleviate some of MISO's transmission constraints, but it will also supply low-cost renewable energy to the PJM market. So we see this is, and if you want to think of it, it's kind of like a similar concept to how Iowa farmers and farmland are being used to help feed other parts of the country. This is an analogy we like to use. So SOO Green will likewise make it possible for Iowa to generate renewable power for other parts of the country. It's a good way to build some efficiencies within the market. So now that we've discussed what's created the need for a project like SOO Green, let's look at some of the project specifics. So as stated previously, SOO Green will connect the MISO and PJM markets at strong grid points in north central Iowa near Mason City and north central Illinois near Plano. And we'll utilize Siemens conversion technology to convert AC to DC and then back to an AC signal. And this equipment will be housed within 2 converter stations, one located at either end of the project. And I'll show a map of where those will be located as well as what they might look like. So we'll utilize 2 525 kV cross-linked polyethylene cables. That's where the XLPE stands for cross-linked polyethylene. And the reason why we'll have 2 cables is because we're DC, one positive, one negative. We don't have 3 cables like AC. So these cross-linked polyethylene cables will be used and placed within dry PVC conduits. No liquid cooling is required. So to give you an idea of size, each cable has about a 5-inch diameter. It's about the size of a smartphone or a large wine bottle. The reason why we're choosing cross-linked polyethylene is because it's a superior insulator. It's the type of insulator that we're going to use. And the reason why we're selecting it is not only does it insulate better, but it's also stronger, it's more impact resistant, and it's more resilient to adverse environmental conditions. And additionally, these cables are marine grade, meaning that they can continue to operate effectively even if they're exposed to water, which is important when you have a project near the Mississippi River. Concerning size, SOO Green is rated at 2,100 megawatts. And then factoring in electrical losses, we'll be able to deliver 2,035 megawatts. To give you some scale, this is enough to power approximately 1.2 to 1.5 million homes. Now, one item that I did want to point out is that there are electrical losses with this, but the electrical losses of an HVDC project are less than a comparably sized HVAC project, meaning that we can deliver more power more efficiently. So the overall distance of the route is approximately 350 miles, but 220 of those miles are going to be located in Iowa. And I've got a map showing a little bit closer view of the Iowa portion of the route a little bit later in the presentation. So once again, this distance within Iowa is within existing transportation corridors, either occupied by the railways or by the Iowa Department of Infrastructure or other roads. Concerning the schedule, we do plan to begin construction toward the end of 2023, and we have a 3-year construction window, so that would bring us to concluding construction at the end of 2026. So with that, one thing I wanted to do is transition to some project differentiators for differentiating SOO Green from a typical overhead transmission project. So as was explained in the video, there are some obvious differences between SOO Green and what you think of traditionally with as a transmission line, or when you think of it, you think of lattice towers and overhead conductors. But SOO Green's quite a bit different for several reasons, and I wanted to draw your attention to a few of those keys. The first difference is probably the most obvious, is that we will install the line underground, not overhead. And this does several things. This limits the impact on neighboring landowners. It eliminates visual impact, as well as environmental impacts. And placing the line underground minimizes disruption due to extreme weather events such as tornadoes and polar vortexes and ice storms and derechos. So the fact that we're underground protects us from a lot of those things that traditional transmission lines have to deal with. The second differentiator is related to the fact that we're underground, as that SOO Green will be co-located in transportation rights-of-way. Now, the right-of-way in Iowa is along rail and road corridors, and our railroad partners have exclusive rights to use the land for their purposes, and where we are required to extend beyond the rail or road right-of-way. Now, these expansions are mainly due to temporary construction requirements or access roads. If that is the case, then my team will negotiate with landowners for an easement on those specific areas. The third differentiator is that we are grid tied, not project tied. So whereas other merchant transmission projects have been in essence extension cords off one or several generators, SOO Green will connect to strong grid points in Iowa and Illinois, which will provide us access to all the generation within that region. So the benefit that gives us is that regardless whether the wind is blowing or the sun is shining in a specific area or a specific project, the electrons will continue to flow, and they can flow in a way that's controllable, schedulable, and deliverable. We will be utilizing modern HVDC technology to make this happen. So this technology is safe, it's efficient, responsive, and it'll provide stability and reliability benefits to the existing grid, both in Iowa and Illinois, in both MISO and PJM. And that's even with the increased number of renewable energy projects in the Midwest. So lastly, as far as the differentiators are concerned, the fifth differentiator is key to you, and if you are an Iowa ratepayer, this is key to you. SOO Green will have no cost allocation. So normally when transmission companies build a transmission project, they will charge ratepayers a fee to reimburse them for the cost of the line. This is standard practice for utilities, and there's nothing nefarious about it, but this is not going to be the case with SOO Green because we're a merchant project. So those who use the line will pay for the line. Therefore, the costs are not allocated to ratepayers in Iowa. And then lastly, although not part of I didn't have this on the slide, but an important factoid I wanted to point out is that there are currently no state or federal tax credits for SOO Green, and the project does not rely on any government subsidies to make it financially viable. So this is when I would normally turn this over to my colleague Raj to discuss various environmental and state permitting requirements that we need to do to connect SOO Green to the grid in MISO and PJM. But since he's out, I ask that you bear with me as I try to cover his material, and I ask that you show me some grace, as this is absolutely not my wheelhouse. So let's dig in and see what happens. Concerning the difference, the review stakeholders, we have engaged with key environmental stakeholders from federal and state levels since the conceptual design phase of our project back at 2016 and earlier. So the Rock Island District of the U.S. Army Corps is the lead federal agency for this project, with the St. Paul District engaged in the small segment for the route in the northeast corner. So we're covering 2 different Army Corps districts. But the Army Corps is coordinating on the biological resources with U.S. Fish and Wildlife and with the SHPOs, which is the State Historical Preservation Offices, as well as with Native American tribes for the cultural resources. So some of the other agencies that are providing environmental review include U.S. Fish and Wildlife, and you can see on the slide, U.S. Fish and Wildlife covers Endangered Species Act and Section 7 consultation. The Iowa Cultural Resources, they cover the National Preservation Act, Section 106, and the Iowa SHPO consultation. The Iowa Department of Natural Resources, which provides environmental review for natural resources, including listed endangered or threatened species. And that's just in Iowa. So we can likewise, and we are likewise coordinating with cultural resources and natural resource offices in Illinois, which provide similar environmental oversight for their respective state. So let's look at some of the actual permits that we're coordinating for the project with these agencies. So slide 9 shows the major statewide permits that are required for project construction. And the first I wanted to draw your attention to is the Iowa Utilities Board, which governs the electric franchise, and that's at the top center of the screen. Now, the IUB franchise is the permit that we'll need to construct and operate a transmission line in rural Iowa. Now, by rural, I mean all those areas that are outside of municipal boundaries. So we started this process with 8 countywide public informational meetings during the initial COVID lockdowns early last year, and we submitted a petition to the IUB, to the Iowa Utilities Board, for a franchise back in September of last year, and that is currently in process now. At the bottom center, so IUB covers the rural areas. The area to the bottom of the municipal franchises, it shows the different municipalities that we need to get a similar permit for those for the 24 municipalities that we're going to be going through. So just like we'll get one permit for the rural area in Iowa, we'll have to get 24 individual municipal franchise agreements for each individual municipality. So the other permits on this screen are that are represented on the screen are environmentally related, and that includes sections 401, 404 of the Clean Water Act, sections 10 and 14 of the Rivers and Harbors Act, and then other permits, other environmental permits such as a floodway permit, ambient water quality permit, water quality certification, and we could go on with those. But those make up some of the key permits that we need for the project prior to construction. So as far as what we've done to date, Sue Green has completed we've completed all the wetland and water body surveys along the entire project corridor. We completed those last year, and we submitted a wetland delineation report to the Army Corps back in March of this year. Concerning the habitat surveys, which we like to refer to those as the birds, bats, and bunnies, we completed those biological resource habitat surveys as well as a present absent survey along the entire route corridor last year, and we used those results when submitting a T&E report. T&E is a Threatened and Endangered Species report to the Army Corps in April. And then lastly, we have filed a preliminary jurisdictional determination request to the Army Corps in April of this year, and we plan to file a pre-construction notification, a PCN, to them in August. And this is along with those joint applications that I mentioned, the 404, 401, 408, and sections 10 and 14. So back to something that I'm more familiar with, slide 10 shows the Iowa portion of the route, which is once again 220 miles. The westernmost point of the project is at the Iowa Converter Station, which will be located approximately 1 mile west of the Mason City municipal boundary in Cerro Gordo County. So the project will then proceed east through 7 other Iowa counties, all along existing transportation rights of way until we get to Cibula. And this is where we will bore underneath the Mississippi and then proceed into Illinois. Now, one point that I wanted to highlight is that the portion of the route along the northeast corner up in Clayton County, the northern stretch, shows where the route diverges. Now, this divergence is due to our desire to optimize the route by using an 18-mile stretch of DOT-owned Highway 18. This will enable us to avoid the Bloody Run area in northern Clayton County, because that Bloody Run area would be much more expensive and complex to construct. So it behooves us, and it's much more environmentally conscious and construction conscious and budget conscious to jump off and use Highway 18 until we get back into the Marquette-McGregor area. So we are in the final stages of obtaining that utility permit with the DOT, and then once that's approved, it will become part of our primary route. So as I mentioned before, one converter site will be placed on either end of the project, and is where we will connect our DC project to the AC grid. So I want to take a look at this next slide that'll show you what the converter site may look like. So slide 11 shows how the converter station will likely appear. And the figure on the left shows a depiction of the likely appearance of the outside of the SOO Green converter station. And the converter site will be one, possibly two large enclosed buildings that will contain the conversion equipment. And it'll, and in addition to that, it'll also appear what will be a traditional substation with transformers and regulators and circuit breakers and lightning arresters, electrical buses, all that good stuff. So that'll be located near the enclosed facilities. So the substation will connect to the AC grid, go into the converter site, and then that is where we go into the figure on the right-hand side, which shows a depiction of the inside of the converter site. And this is where the magic happens, and then the AC to DC conversion process takes place. And then once we convert to DC power, from there until we reach the other converter site, that entire stretch will be completely underground. So whether we use a trench or a trenchless approach to install it, it will ultimately be underground with no visual impact. So Cerro Gordo County will contain the only converter site in Iowa, and will be one of the only two converter sites for the entire project, one being placed at either side of the route. So before we open it up for questions, this is the last slide. We do have some others if questions require it, but this is the last formal slide. But before we open it up, I did want to close with this slide, which highlights some of the various stakeholder groups for the project, as well as some of the benefits that are for each group. So we're going to start at the 12 o'clock position, and then we're going to move clockwise. So we'll start with the railroads, which obviously benefit from the project because this generates a new revenue opportunity. And if you really want to think about it, railroads have been involved in the energy industry from the beginning. This is nothing new. The only difference is now, instead of shipping raw fuels such as coal, oil, or gas, their routes are being used to ship the end product, which are electrons. So we think this is a good use of an existing corridor. Next, renewable energy developers will benefit from the project because it will open up new market opportunities. So we are relieving those transmission constraints, helping the MISO market work more efficiently, and also open it up for additional projects for renewable energy developers. Retail consumers in Illinois and Iowa both should expect to see some economic benefit because of increased market efficiencies. And then, specifically, retail customers will benefit in Illinois because of lower rates. We'll be bringing low-cost renewables into their market. And then Iowa should see some additional revenue share from the exported power and additional projects being built. C&I customers, which stands for commercial and industrial customers. Some examples of that are manufacturers, data centers, municipalities, or even utilities, will benefit by being able to directly access low-cost clean energy to meet their corporate and state sustainability goals. As far as the state, the clean energy goals will benefit because SOO Green is a large-scale clean energy resource that'll help meet those state mandates. The grid operators will benefit from SOO Green because it's a dispatchable clean energy resource that will enhance grid reliability and resiliency. And if you remember back from Natalie's presentation, where she was talking about dispatchability and the responsiveness, we will be extremely responsive. Within less than 1/100 of a second, we can go from 100 megawatts up to 2,000 megawatts, whatever the grid operators need. So they can almost treat us like a generator, because we can immediately respond faster than any other type of generation. On the jobs front, the labor unions will benefit from the opportunities. We will have a project labor agreement, and so we'll have skilled trades that'll be additional construction jobs. And then lastly, the communities and landowners themselves will benefit because of the new construction jobs coming through the area, the economic development around construction and the operation phases. And then, additionally, we're very bullish about this type of project because it introduces a new way to connect large electrical markets in a way that mitigates the need for private land, mitigates the need for eminent domain. It minimizes environmental impacts, it eliminates visual impacts on private land, and it does away for the need for overhead cables and towers. So we realize that no project is perfect, but we're pretty excited about SOO Green and feel that we offer benefits to many of the different groups. So that concludes the formal portion of our presentation, but Steve and I are available to address project and industry related questions that you may have. And once again, thanks for the opportunity.
Yeah, thank you, Neil. This was great. I'm gonna make sure that I read through this list, and if I get through some and I've missed some, please do go ahead and just chat them again. We've got a bunch here that have been answered in the chat box, and I may skip over those just in the interest of time. But my big question for you, just in terms of how this is operated, is that, yeah, I mean, it is built to be a more or less an exporter of a wind from Iowa into the eastern markets, but it physically can go the other direction. Do you expect that it will sometimes? Is that going to be sort of just an emergency only benefit for folks in Iowa, or is really more, how much back and forth is there going to be, do you expect?
I'll address it initially and then let Steve tag on if he wants to. To be honest, SOO Green is agnostic toward the electrons, but based on the market demand, it is mainly going to be for renewables, and that's going to be predominantly the wind. As far as the direction, it's once again, this is based off of the demand, which is primarily going to be coming from the west in MISO to the east. So it's going to be, most of the time the electrons are going to be flowing east, but they can conceivably flow both ways. There will be some market balances, and if you have extreme weather events such as the derecho, for example, if you have those outages, or just to protect from brownout situations, or if say if there are extreme weather events where you don't have the wind blowing in MISO, but you need to import power, electrons can flow both ways. And Steve, I don't know if you had anything that you wanted to add on to that.
No, I think that's just fine.
Great.
Okay.
Thanks, Neil. That's good. I'm just going to start at this top, and I'm going to show that I try not to miss any of these. How long are the drain tiles going to be out of commission when this project is in place?
That's a good question. Yeah, drain tiles. It will be from the time that we open it up to the time that we close the trench will be less than a week. And actually, the time that we cut it, it'll be a matter of days, if that long.
Yep. So just long enough to dig the trench and put things in place.
Correct. And the only reason why I'm kind of hedging my bet is just because of rain situations where we have to accommodate specific things. But if possible, we'll be in and out within a day.
Yeah. So I do have a question. I'm not exactly sure. Maybe they can elaborate. I'm just going to read it word for word. But what about where the railroad does not own the land but only has an easement?
Yes. So we have now that is something that needs to be settled by the IUB. We are allowed by the railroad to use their land rights to place it within that, and this falls underneath a railroad use. So even though it would be an easement, it still falls within a railroad use for that. So the only exception to this is there is approximately a 1 mile stretch along in Bellevue. And I think I actually saw Abby Scribner's name. She's a city manager for Bellevue, which I'm glad that she joined. That is the one unique section along the entire stretch in Iowa where where there is no shoulder, where the railroad owns only from rail to rail, or has rights from rail to rail. And that will be a situation where we need to get an easement. But everything else, we will be able to use the existing land rights, whether they be fee simple or an easement with the railroad.
Okay, great. Sorry, I'm combing through a lot of these questions here that are on. I'm going to read this one out just again as well. This is from Andy, our director at the Energy District. Just noting that 2 gigawatts of power is about 17% of Iowa's current wind capacity. So is this project, we know the answer to this in some ways, but is this project meant to allow the export of current wind production or new wind farms?
This is Steve, I can try that.
Go ahead, Steve, hit it.
Sure, yeah, and I did try to answer this in the chat. So SOO Green is going to enable export of Iowa wind resources, just like Iowa obviously grows corn and beans and exports corn and beans all around the United States. The renewable energy resources of Iowa are a natural resource of the state. They provide a lot of benefits to the state, and so SOO Green provides a unique export opportunity. And so if there are existing resources that have unused capacity or potential to contribute to SOO Green and serve an external market, they're welcome to do so. But we also think that SOO Green is going to spur and trigger an opportunity for several thousand megawatts of new renewable energy development in the upper Midwest, including Iowa, to serve the line and take advantage of the export opportunity. And that will create a lot of new jobs and investment, economic development in Iowa. So really it's a yes and answer.
Yeah, I'm curious, can you talk a little bit about how the market-based system works? Who is actually the person paying when the line is used? Is it a generator at one end that's selling to someone else on the other, and then they pay you for the transmission just per
That's right.
kilowatt hour?
That's right, Joel. Yeah. So we're basically like a pipeline, and it's a similar kind of economic model where we're sourcing the energy on one side, on the Iowa side, and we're selling it to customers on the PJM side. So the customers in PJM, whether they're a utility serving commercial residential customers or whether they're a private corporation serving their own production facilities or municipal utilities, will be entering into contracts with SOO Green and for access to the resources on the Iowa side. And so it's really as simple as that. And SOO Green charges a transportation fee. And that's our business model. So we're basically operating the line to enable those electrons to ship from Iowa to the PJM market and are basically serving to connect buyers and sellers to take advantage of this commercial or market-based opportunity.
Excellent. I'm going to have a couple questions I'm going to try to combine here just on the footprint of the project. You want to talk, obviously, that when the trench is buried and that's gone, maybe people might not even know that it was there. But for the sites that do have some footprint, how big are these converter stations at either side, and what does it look like? I think everyone's curious. How do you get over the Mississippi? What does that look like as well? You're going to need a bigger spot to be making those long directional borings from one side all the way to the other, or are you going to be kind of leapfrogging across?
So I'll cover the converter site question first. And now this is a site that's in Spain, but this is similar to what it should look like. We should have one or multiple large enclosed facilities that's within a large fenced-in area, and then you'll have, in addition to that, what appears to be a traditional substation. The overall area in that is probably going to be in the, I would say, 30 to 40 acre range. That we have secured both sites, both near Mason City and in Plano, and we have enough for the site itself, some additional storage, and then any buffer area to accommodate whatever siting requirements and visual appearance it needs to have with the facade of the building and things like that, just with normal special use permits, conditional use permits, making sure everything looks nice and comparable to what else is in the city or in that area. So we have enough. To answer the question, is probably approximately 30 acres, but each site that we've got is over 40 acres. So we have some buffer area with both of those. So as far as the Mississippi crossing, yes, that is absolutely something that I want to be there when they do that as well. That will be absolutely one of the horizontal directional drill locations where we have those three methodologies that were described in the video, where you've got open trench, jack and bore, and horizontal directional drill. Horizontal directional drill is going to be one where we need to have, it's about 1/10 to 1/4 of an acre area footprint that we'll need. I think it's about 50 feet wide, about 200 feet long, where we'll need to set up for that horizontal directional drill. And so we'll have an ingress and egress on either side, and we will bore through and then grab a conduit and pull it through, and then we can pull the cable through that. So we will have redundant lines underneath the Mississippi. So that way, if obviously that's going to be one special area that it would be difficult to repair. So we want to be able to quickly switch from one circuit over to another if one fails. But so yeah, that will be a special splice or a special section of cable that will be longer than most of the rest of them. Because we don't want to have any splices underneath the Mississippi River, and those will more than likely have to be brought in actually from the river itself, because the spool will be too large to transport with U.S. infrastructure on the road.
Wow.
Yeah.
Okay. Well, I think I've managed to answer everyone's questions on here. And so if there's something that I forgot or I didn't get specific enough, go ahead and put something in the chat. And I'll make sure that we get it before we say goodbye. I think we answered the questions about cost. And I think it really is interesting to think about this project as a totally market-based project. Seems like that's a good way to actually pass costs on to the people who are using it, and that the risk is with you guys as an investor company if something were to happen, right? I mean, as far as no one's going to be on the hook for this project if it goes south, other than the company that built it. Yeah,
correct. I did see a question from Lyle. Actually, well, Steve. Yeah. So Lyle had a question about detecting faults within the line. First off, electrically, if for some reason, now we'll be at least three feet, in some sections, significantly deeper than that. But if for some reason the line is damaged and there's a fault in the line, it will immediately cut off within less than 1/100th of a second. It responds extremely fast. Now, as far as us detecting where those outages are going to be, like Steve said in his text or in his chat response, there will be sensors. We'll have a fiber optic line going along that route that will help us isolate where those problems are. And then because of how we actually do the install, this is pretty well thought out as far as regardless of whether we do trench or a trenchless approach, the conduits will be put in place, and then the trench will be closed up. And then after the trench is closed up, then the cables will be pulled through their individual conduits. So what that does is that if there are any faults after the fact, and if we have to repair or replace a certain section, we don't have to open the trench back up. So unless there's something catastrophic or geological that causes some damage to the conduit itself. But as long as the conduit's intact, we don't have to open the trench back up.
So Lyle had another question here just on batteries, and I'll add on to that. Is there any sort of thought of putting batteries at either end, and is that easier to do because it's DC power rather than AC power, or are we talking the scale of the transmission line is so big that maybe doesn't make a lot of sense yet?
Steve, I don't know if you want to touch that.
Sorry.
I can address it, but I don't know if, yeah. The question was battery storage.
Yeah, so battery storage
and planes.
Yep, battery storage technology is evolving rapidly, and SOO Green's a very large project, and so currently most utility scale batteries aren't of the duration that really matches our need at the moment, but we're a few years away from commercial operations, and so we're certainly closely monitoring how battery capabilities are evolving, and certainly that could be a very nice complement to how our project is designed. So certainly we're open to that and looking at it.
Okay, Steve, you answered this question in text already, but do you want to just expand on it at all about how the underground and the DC nature of the project mean lower line losses than a typical transmission project?
Yeah, so I mean, HVDC, whether it's overhead or underground, is going to have lower losses than an overhead alternating current line. Because higher voltage is a more efficient way, particularly over long distances. Now, distance matters in terms of line efficiency and whether you're going to use an AC or DC technology, but the underground aspect of it allows for a even higher voltage cable to be installed. So partly because it requires a heavier cable than is normally able to be installed overhead. So there are advantages of going underground, both in terms of security for the line, climate resilience, extreme weather resilience, obviously the environmental and visual benefits, and we can install a higher capacity cable that makes the project more efficient. So the more power we can transmit over the line, the more efficient the project becomes, and the line losses, of course, are minimal when it comes to HVDC technology, under 3%.
Yeah. Great. Well, hey, thank you guys so much. I'm going to ask one last question here from Andy, and it's a long one, so we'll leave room for you guys to maybe have a long answer to it as well. And I'm gonna try to do him justice while cutting him down just a little bit in terms of the length of the question. But so he's trying to say this isn't a gotcha question. He's a genuine question that he wants to ask here, and to ask about there are benefits to the transmission and having it underground. It's an innovative model, but I think what he's getting at here is that this does open up Iowa's market to of sellers to a larger market. And is it possible that this could increase the wholesale costs in Iowa and on the Iowa side of the project? And does that have any impact on the end retail customer?
Yeah, and I can address that quickly. Once again, Steve, if you want to add on to that, that's fine. But long story short, this is an arbitrage situation, which I think that Andy is referring to. And are we going to collapse the arbitrage? And this is something obviously that we've modeled that it does not work if we want to take enough power. We have to have the economies of scale to justify the project of this size, because you've got a 350-mile project, which is 700 miles of cable with copper conductor and two close to $250 million converter sites, individually. You have to be able to justify the cost of the project. But we have done, obviously we've done the math. We could double, possibly triple the size of this project without having, any adverse effect on the markets. The price difference is still there. So to answer your question, Andy, the project will not be large enough to adversely impact Iowa ratepayers. It doesn't work if it does for us.
Yeah.
Yeah, I'd only add, I think it's a great answer. I think the only thing I'd add is that, as I mentioned earlier, we are going to be creating new opportunities for new supply on the Iowa side. And so, keeping that supply and demand equation in balance as we bring more supply on to the system on the Iowa side, that obviously has a price suppression effect, or will at least sort of provide some pressure against any upward prices. So just keeping, imagine you're holding demand constant on the Iowa side and you're increasing supply. Even if that supply is being built for export, that means we're not cannibalizing necessarily the existing supply. So I think that's part of why this model works. And we wouldn't have been able to raise the private capital, over $2.5 billion for this project if the economics were not durable over a long period of time. So we're very confident about that.
Yeah, great. Well, anything else you guys want to say? I think we're getting close to our hour of time, and I want to thank everyone for joining us. You guys want to leave any last words, and we'll talk about some things that we've got coming up on the Energy District calendar.
Just thank you for the opportunity again. And if you don't like renewables, you don't like transmission.
Excellent.
Well, we appreciate the time. There was a really nice piece on CNN that aired last Thursday, and I think it aired again last night. And so we can certainly provide a link to that, Joel, for this group profile.
Yeah, that's great. Any information that you want to give to us, we can post. We typically post these videos, and we will post this one on our website, kind of our archive of energy breakfasts. And
Sure.
if there's some info that we can just include in this quick description, we can post that as well.
Great. Let me grab the link, and we'll add it to the chat in just a second.
Excellent. Well, great. Thank you, Neil. Thank you, Steve, for joining us. Thank you, everybody, for calling in today and providing us with some good questions for discussion. We will have another energy lunch next month. And unless Heidi saves me, I won't be able to remind you all what that is. But check out our newsletter. If you haven't signed up for our newsletter already, it's energydistrict.org, and there is a sign-up page on the first piece. Oh, Heidi reminds me that next month I will be giving a presentation on home electrification. So how you can make your house solar powered. Is the quick way that I like to sell. So thanks again to everybody. Thank you, Steve and Neil, for joining us. And we'll see you all next month.
Thank you very much.
Thank you.